Question number 9 involves this product function where we have x times the sine of pi x, and this is what the graph looks like, and we have a restricted domain. First, the question asking is find the gradient at x equals a quarter. So what's the gradient at that particular point? So I'd like to find the derivative of x, then set x equal to 1/4. So f of x equals x times the sine of pi x. Now the derivative of this is going to be a product rule because I've got x here and I've got x inside the sine. So u is equal to x, so u dash equals 1, and v equals the sine of pi x, which means that v dash will be the derivative of sine is the cos of pi x, and the derivative of the inside of the chain is pi. So f dash of x will be this times this, the sine of pi x plus pi x times the cos of pi x, which means that f dash of 1/4 will equal the sine of pi on 4 plus pi times 1/4 times the cos of pi on 4. And the sine of pi on 4 is root 2 on 2 plus pi on 4 times root 2 on 2, because the cos of pi on 4 is also root 2 on 2, and I've got to put it in this form here. So I've got root 2 on 2 plus root 2 pi on 8. So all on 8, so 4 root 2 on 8 plus root 2 pi on 8. Take out the root 2 as a common factor, 4 plus pi, all on top of 8. And I think that that will be the same as this form here. And they're all positive integers, so if I copy that and I paste that down here, so rearranging it into the same form, I'm going to have root 2 pi plus 4 on top of 8. So a equals 2, b equals 4, and c equals 8, and there's going to be my answer to the gradient at x equals 1/4. Part B says, given this information, find the area bound by the graph of f, the x-axis, and the interval 0 to 1. So what that area there. So I can see that it's a positive area. So first up, since it's worth 2 marks, the area I'm interested in is the integral from 0 to 1 of x sine of pi x dx. And that's what I'm looking for. However, I can't take this antiderivative because I've got x's in 2 different spots, but that's where I'm going to use the integration by recognition from here. So I know that from this line, therefore, x cos of pi x will equal the integral of the cos of pi x minus pi x sine of pi x dx. And I can see part of that in there in the integration by recognition. So x cos of x pi equals the integral of the cos of pi x dx minus pi integral of x sine of x pi dx. If I move this to the left, that will give me pi integral x sine of pi x dx should equal, move that over, the integral of cos of pi x dx minus x cos of pi x. And the integral of this is going to be, the integral of cos is sine, positive, but my a value is pi, so 1 on pi sine of pi x minus x cos of pi x is going to be my antiderivative. Therefore, putting that all together, the integral of x sine of pi x dx will equal, I move the pi over, 1 on pi squared sine of pi x minus 1 on pi x cos of pi. And if I'm going from 0 to 1, then I can put square brackets around that and go from 0 to 1 and find out the exact area. So it's going to be 1 on pi squared sine of pi minus 1 on pi, 1 times the cos of pi, minus 1 on pi squared the sine of 0, plus 1 on pi 0 times the cos of 0. That's 0, that's 0, so that's 0, that's equal to negative 1, so it equals 1 on pi square units. So that area in red that was shaded is equal to 1 on pi square units using the integration by recognition. I had to use this fact to then isolate this antiderivative, which was going to be this antiderivative, but the problem was that I had a pi there. So I had to take the pi out and I had to divide both sides by pi as a result to get the expression being the expression that I wanted. Okay, that's A and B.